is chemical kinetics, right? Basically, to understand basically what is chemical kinetics, we will see chemical reaction, and number two, we'll discuss about how fast the reaction takes place. What is the relationship between speed and spontaneity? Do you know the meaning of the word spontaneity? This word? Yes. Do you know the meaning of the word spontaneity? By itself, or will occur or not, the feasibility of the reaction or not, will the reaction take place or not, right? That is spontaneity of the reaction, spontaneity of the process, right? Just like this, if I say, uh, will you learn something in my class spontaneously, like for complete 1 hour and 45 minutes now? Yeah, it means you are predicting that the process will be spontaneous, right? And you will be listening to me, and you will be enjoying the subject, and then you will be understanding the fundamentals, right? And you will be able to recall in the examination also, right? So that is the spontaneity you're predicting. If you're predicting this thing, then what is the thermodynamic criteria for the spontaneity of a reaction? Yes, what is thermodynamic criteria for the spontaneity of a reaction? Yes, tell me something about the thermodynamic aspect of the spontaneity of a reaction. Under what condition the reaction is spontaneous? Delta S is very good, greater than zero. Very good. Entropy change must be positive. Very good. Yes, perfect. Anything else? Yes, students. You have passed a +1. Exothermic, delta H should be negative. Okay, fine, perfect. So delta H should be negative, delta S should be positive. But tell me that thermodynamic quantity which control both of these. Yes, should I tell you now? Very good, Yashan. Perfect. So delta G is equal to delta H minus T delta S. And this should come out to be negative, then only the process will be spontaneous in nature. The process will be spontaneous in nature, right? Right. So we'll be discussing in this chapter what is the relationship between speed and the spontaneity of a reaction, right? Speed is related with the rate of reaction, and spontaneity is related with the feasibility of a reaction. So the area of chemistry that concerned with the reaction rate and sequence of steps by which reaction occurs is called as the chemical kinetics, right? Feasibility means, again, it's a possibility of reaction will take place or not. Getting me, Yash? Whether it is the process is spontaneous or non-spontaneous. That is a prediction on the basis of the delta H and delta S, right? Till now, any doubt? Everything is clear. So, how do you explain the rate of reaction, or we can say the speed of reaction? If I had been teaching you physics, if I had been teaching you physics, then I would simply have told you speed is equal to distance upon time taken, right? I hope I'm right in this formula. Being a person of chemistry, I'm writing some physics. Yes. Okay, fine. That's good. I'm passing your exam now. Okay, speed is equal to distance upon time taken, right? And now, when I'm going for a reaction in test tube, my chemical is not going to cover any distance, right? It is going to remain in only the test tube. But only thing is time will change. Time will change, but not the distance, right? So what change will be there in the test tube so that I can decide the speed of the reaction? Amount of the product obtained. Very good. Okay. Uh-huh. So it means the amount of product will increase, right, with the passage of time. or we can say the amount of the reactant will decrease with the passage of time. So I can draw a graph here between the concentration versus time graph. Reactant concentration is this much when time is equal to 0. And as the time increases, what will happen to the concentration of the reactant? Let me know. What will happen to the concentration of the reactant? Very good, Ame. It is going to decrease, right? Very good. With the passage of time, the concentration of the reactant decreases. And now, with the passage of time, what will happen to the concentration of the product? Increase. Yes. At time 0, it goes like this, right? This is for the product. So, basically, here a rate of reaction means basically change of concentration upon change in time. Change of concentration upon change in time, right? And rate is equal to, it is a decrease in concentration of reactant upon change in time. Or I can say it is an increase in concentration of the product upon change in time. Right? Are you getting me? Yes, friends. Are you getting me? Okay. It means you can say rate of change of concentration, rate of change of concentration of the reaction, rate of change of concentration with respect to time. Anirudh, make a statement correct. It's a rate of change of concentration with respect to time. That is the rate of reaction, right? It means the concentration is decreasing upon change in time, right? Final concentration minus initial concentration. And unit is equal to, the unit of the concentration is moles per liter and time is second inverse. Is that clear? Right? Getting me, all of you? Fine. Still, please let me know if you don't understand anything. Be very, very open to me. Let me know if you're not understanding. Till this point, are you everything clear? Let me know. Good, very good. So, how many types of rate of reaction? See, if I ask you in physics term, how many speed of any process? Suppose a car is moving from point A to point B in time t, it is moving with certain speed, right? Now, what is the type of the speed? Then what is say in physics? Because you might be good at physics. You are student of non-medical. You might be good at very good at physics. So let me know. If I ask you, what are different type of speed? Uniform and non-uniform. Very good, Shrija. Very good. Anything else? Instantaneous. Murli, I hope you want to say instantaneous. Yes, instantaneous. Average, very good. Average speed and instantaneous speed, very good. Uniform and non-uniform, very good. Does the reaction takes place with the same speed throughout the process? No. Certain reactions are slow in the beginning and then become fast in the mid, and again it slows down at the end, right? So they may not be uniform, right? They should not be the other, right? Okay, fine. So in chemistry, we'll be discussing here two types of rate of reaction. Number one is the instantaneous. Yes, yes, Pranav, absolutely correct. Reaction acquires the state of equilibrium after some time. Right, you are absolutely correct. Right. So instantaneous. Oh, you. Okay. Okay. instantaneous rate of reaction, and talking about the average rate of reaction. Okay, before I go to the chemistry of the average rate, right? What do you suggest in terms of physics? What is average speed of the process? A car is moving with some average speed. What is the meaning of the average speed here? You let me know. Yes, please. Sum of the speed upon total time, total distance upon total time. Okay. Total distance, sum of the total speed in given interval. Okay. Yeah. Okay. Fine. Sum of all the speeds upon total time. Googling. Okay. Okay. Now, let me explain uh, some physics part here. Then I'm coming back to my chemistry also. Right. In this chapter, I'll be like shifting between the two subjects, physics and chemistry, basically science. And I'll be giving you some examples from the physics, some example from daily life also, and some example from chemistry, of course. Major part will be chemistry only. Suppose I say I have object, not object. Let me a train is there, and right now it is in Chandigarh. Right, it's my place here. I'm in Chandigarh right now, and I have to go to Delhi, and the distance is roughly 250 kilometers. And the train reaches from Chandigarh to Delhi non-stop, non-stop. Let it be non-stop. Otherwise, there are some stops might be there, right? So it reaches in 4 hours. It takes 4 hours to reach from Chandigarh to Delhi non-stop. It is Shatabdi Express. So can you tell me what is the speed of my train? What will it do? Yeah, what you have done, what you have done actually, what you have done, you have divided distance upon time taken. Absolutely correct. Now, does the train move with this constant speed of 62.5 kilometers throughout the 4 hour time? No. In the beginning, when it is just starting from the railway station, railway platform of Chandigarh, it is moving with the speed of, let it be 5 kilometers per hour, right? As it leaves the platform, it acquires 10, then 20, then 30, then 40, then 50, right? As it crosses the city and goes into somewhere jungle part, there the speed is 90, 120, 130, right? And as it is crossing to the other railway stations, it might slow down sometime, right? So ultimately, it is going to it is reaching to the Delhi, very close to Delhi. If you have traveled to Delhi before the railway station, there is roughly a distance of 10 kilometers, where all the trains slow down. All the trains slow down because of the red signals or something. They don't get the signal to move ahead, right? So there the speed is again 10 kilometers per hour or 20 kilometers per hour, and sometimes even stop also. But roughly it takes 4 hours. So on the average, this comes out to 62.5 kilometers per hour. And then we say it's an average speed, right? But now, if I say I have an instantaneous speed now, instantaneous speed is the speed that is being shown in the speedometer, right? In the speedometer, at a particular time, what is the speed of the vehicle that is shown in the speedometer? So that speed is called as the instantaneous speed of reaction. I hope you're getting me. Yes. Yeah. If you find any problem right now, please ask me. It's a very, very important topic for your competitive examination for the board level also. Anirudh, what should I repeat? Anirudh, what should I repeat? I have taught, I have given you the whole story. Should I repeat the whole story? Instantaneous, okay. Okay, fine. Instantaneous means Anirudh, do you drive some vehicle like two-wheeler or so? Okay, yeah, you drive Ferrari. Okay, that's good. Okay, when you're driving, if you look at the in front of you, um, I mean, don't. I am expecting you to drive Ferrari only, not less than that. It's not a matter of kidding. You may be kidding, but I'm quite serious. One day you will drive Ferrari, your own Ferrari, right? It's not a matter of kidding. You may ask today in kidding and joking, but these jokes generally get materialized. Yeah, in your get your clear your IIT JEE, go to the advanced level, and once you're in the IIT, after passing this IIT, 4 years in the IIT, Google or Facebook or many other companies, or you may have your own company, right? You're the director of your company, and you can easily acquire Ferrari. Ferrari is not a big issue. The big issue is the preparation for it. Yeah, startup is the better. Yeah, good. Fine. Come back to the topic now. Speedometer. That the instantaneous speed means the speed at a particular instant of time. Particular instant of time. Right? That's good. Okay. So Anirudh or Ame, Ferrari is not a big issue. I am always do you know like these days I also big very dream I dream very big like this. I sometimes dream I am daily what I do I take my checkbook and sign with the Hindustan Aeronautical Engineering engineers for company. I sign up a check in the name of Hindustan Aeronautical Limited. What do you write there? That I am giving this check to the Hindustan Aeronautical Company for getting my personal jet plane. Right? Initially, I was just kidding 2 years back, but sincerely, seriously, I sign it like this sometimes, once in a week or so. And imagine that I have my own for on jet plane, personal jet plane. Right? That's good. So Ferrari is not big issue. The big issue is the preparation before that. So prepare very well now. Go into the IIT, right? Come back to the topic now. Right. So two kinds of rates are there. One is the average rate, other the instantaneous rate. So average rate means overall rate measured over a time interval. So change of concentration of one of the reactant the product upon change in time, right? I think this is not a big issue. Very, very simple things are there on the screen. And fine. So this is the graph I'm showing here. See this first graph here. This graph. The concentration of a reactant is decreasing with time. And the concentration of product is increasing with time. Getting me here? This is the reactant, the concentration is decreasing with time, and the concentration of product is increasing with time. At time t1, concentration is AT1. At time t2, concentration is AT2. So average rate of reaction is change of concentration. Change of concentration is A T1 minus A T2 upon change in time. That is equal to T2 minus T1. This is the average rate of reaction. Right? Okay. All of you getting me? Good. And now, the same thing I have given here now. Now, you can see the AT2 is the final concentration minus initial concentration. This will come out to be negative. You know that AT2 is smaller value as compared to AT1. This is a negative value. Can rate be negative? Can a rate of any process be negative? No. A rate can be only positive. A rate can be only positive, right? But only the negative sign indicate that the concentration of the reactant is decreasing with time. That's it. Otherwise, rate cannot be negative. Rate cannot be negative. Rate can be either positive or zero. Yes, zero is possible. Prana, very good. Rate is possibly, yes, it can be zero. It means reaction not taking place at all. Prana, very good idea. Rate zero, it means action is not taking place at all. Rate is positive, rate is taking reaction is taking place. But rate cannot be negative, right? But here, if the minus sign is appearing here, that simply implies that the concentration of the reactant is decreasing. That's it, right? Leave this part. Yes. So positive sign shows that the concentration is increasing, and negative sign shows the concentration is decreasing. Okay, just read this page. Let us continue now, right? So take up this example now. Time in second, and the concentration of the A is in some molarity. So time 0, concentration is 50. After 10 seconds, 43. After 30 seconds, 32. After 50 seconds, 23. What is the average rate of reaction in the consecutive time intervals? What is the average rate of reaction in the consecutive time intervals? Right. Have you gone through this data now? Okay. So Lalit, how have you got this 1.64? See, friend, in time interval, the question was not the overall, but in time interval, 0 to 10 seconds. See the question here. 0 to 10 seconds, that change of concentration is 43 minus 50, minus 7 upon 10. Got it? 10 to 30 seconds, gap is 43, 43 by 20. So at the different interval of time, you are getting the different rate of reaction. And the negative sign only indicating that the concentration reactant is decreasing with time. Getting me, friends? Okay. Now, so what is the instantaneous rate and overall rate of reaction? Now we're discussing this, right? You know, basically, what is this instantaneous rate and what is this? Now, in this graph from here, with the concentration of the A is decreasing, you can see here the concentration of A is decreasing. How to find the instantaneous rate of reaction? What do you do? Suppose I want to find the rate at this time interval t. Draw a perpendicular here, and at this point of the line, draw a tangent that I'm showing by the blue line. So this to this is the time t, and this to this is the change of concentration, right? So find the intercept along the coordinate and abscissa. And tan theta, you know what tan theta now? This upon this means this upon this is the tan theta now. So minus c upon delta t. So limiting value, this dc upon dt, right? Negative sign only indicate the concentration is decreasing. Yes, yes. In the board examination, we have to show negative sign, and then you have to show that negative sign indicates only that the concentration is decreasing with time. Okay. this part. Now, I'm talking about the instant our overall order of reaction, and in terms of rate of appearance and disappearance. This is my reaction here. I say A is the reactant and B is the product. In terms of the quantity wise, if I read this quantitatively, I can say 1 mole of A, if reacts, it gives 2 moles of B. If 1 mole of A disappear, in the same time, 2 moles of B appear. Getting me? It means the speed of the disappearance of the A is half of the appearance of the B, or we can say rate of appearance of the B is twice as compared to rate of disappearance of A. Are you focusing upon my words? Listen very carefully. I say the rate of disappearance of the A is half of the rate of formation, rate of appearance of the B. Right? So rate of disappearance of A is equal to rate of appearance B upon 2. Right? So rate of disappearance means dA upon dt and half of the rate of the appearance of dB upon dt. Here I am not using the minus sign, but I am using plus sign. And this negative sign indicates that the concentration is decreasing. I hope everything is clear. Right. Now, in terms of the differential rate equation, so what you have to do is, it will be good if I show it on a plain sheet. That will be much better. When I write myself, that will be more clear. I say A moles of the A react with B moles of the B. It gives C moles of C and D moles of the D. Then rate is equal to minus dA upon dt, but divide by the coefficient A is equal to minus dB upon dt and now divide by dB, right? Now I say dC upon dt divide by the C, and now d upon dt divide by d. Is that clear? Whatever the coefficient is here, divide by that value. Now, question is why so? Why I'm dividing here, right? Yeah, why should we divide? Yeah, of course, Murli, a very good question. Why should we divide? What is the fun in doing this thing, right? Okay. Now, I'll prove it with one example here. So I should say the time in which 1 mole of nitrogen react, in the same time 3 moles of hydrogen react. Please listen to me very carefully. The time in which 1 mole of nitrogen react, in the same time 3 moles of the hydrogen react. It means rate of disappearance of the hydrogen is 3 times the rate of disappearance of nitrogen. The speed of the disappearance of the hydrogen is 3 times as compared to the speed of the disappearance of the nitrogen. Are you listening to me carefully? So we can say here a rate is equal to, I'm just writing here, d n2 by dt is equal to minus 1 upon 3 dh2 by dt. Now what I spoke there is now I'll prove here. Suppose I say I have to express in terms of the rate of the disappearance of the hydrogen, then I'll say minus dh2 upon dt is equal to 3 times minus dN2 upon dt. See here, very important. Rate of disappearance of the hydrogen is 3 times the rate of disappearance of the nitrogen. Is it proving? Is it proving what I say? Yes. Same way, I can say it is equal to minus dNH3 upon dt divided by the 2. Can I say that rate of the rate of the appearance, I should do plus sign here. Rate of the appearance of the ammonia is twice the rate of the disappearance of the nitrogen? Yes or no? Yes? Getting me? Yeah. So it means dividing by the coefficient makes sense here now, right? Pranav, okay, I'll repeat part here. Rate of appearance of the ammonia is twice the rate of the disappearance of nitrogen. I'm just proving this thing, right? So if I write the rate here, that is equal to minus dN2 upon dt. So that will be equal to, okay, I write it once again. That will make it better understand here. I say minus dN2 upon dt is equal to 1 upon 2 ammonia upon dt. From this equation, if I write the rate of appearance of the ammonia, can I say it is equal to twice of the disappearance of the nitrogen? And you can see here that the rate of the formation of ammonia is twice the rate of disappearance of nitrogen. Right. So everybody is now clear? Okay. For this question, I have given you the rate. Yes or no? Yes, I have given already. It's a minus dN2 upon dt is equal to 1 upon 3 dH2 upon dt is equal to 1 upon 2 ammonia upon dt, right? Okay. What will we write instead of nitrogen in the rate? I mean, I'm not getting your question. I'm not getting your question. What will we write instead of nitrogen? Still, I'm not getting you. Minus sign. Minus sign is indicating only that the concentration is the nitrogen is decreasing here. Hydrogen also decreasing here. Rate of minus sign only indicates that the concentration of nitrogen is decreasing with the passage of time. And here also minus sign. But here, for the product, I'm not using minus sign. I'm using a positive sign. It means the concentration of ammonia is increasing. Right? Now, I think very clear now. Now, what are the factors which influence the rate of reaction? Very good, Ame. Temperature. Fine. Anything else? Ame has given one factor. Catalyst. Very good. Pressure. Catalyst. Anything else? Volume. Neha, you want to say volume? Yes. Concentration. Good. Concentration. Okay. Anything else? Number of moles means basically concentration only. Number of moles means basically concentration, right? Anything else? Okay. Let us discuss briefly about all this. What happens with the change of temperature? What happens with the change of temperature? Rate increases. Very good. Mhm. Rate increases. Okay. You are saying rate increases. Is your statement applicable to all the reactions? No. Very good. No. It means you can't say that with rising temperature, rate will increase. It can decrease also in certain cases. Can you give me that example where it decreases? No, no, no. With the rise in temperature, the rate will decrease. Give me that example. Okay. I'll discuss in detail all of that, but let me tell you briefly here that rate versus temperature, in most of the cases, it increases. But rate versus temperature, for the biological phenomena, it first increases and then decreases. It first increases and then decreases for the biological phenomena. For example, uh, I will give you one simple example from biology here, right? One daily life example rather daily life example. Yeah, rather I'm giving that example. See, have you ever seen um, curd formation? How do you make curd? How do you make curd? You just add lactobacillus bacteria. Yeah, lactobacillus bacteria, something in the already made curd. There is a bacteria that is containing bacteria known as lactobacillus bacteria to the milk. When you're adding that thing to the milk, what is its temperature? What is the temperature maintained at that temperature, at that condition? Yes, Gurleen, let me know. Room temperature. Very good. Right? It is not the cold temperature, it is not the boiling temperature, but we say the temperature is slightly higher than the room temperature. Go ahead and make it very more clear. Slightly higher than the room temperature, right? So, slightly higher. What happens that time? Because the biological phenomena, the mitosis process is maximum in the temperature range of 20 to 40 degrees Celsius. Under this temperature range, the mitosis process is at its peak, right? And we maintain the temperature during the whole time of the curd formation. Clear? If we decrease the, if you maintain this temperature, the curd formation can take place in 4 hours to 5 hours, right? And you might have observed, yes, Anirudh, I'm coming to your question. What about the winter time? Absolutely. If you put that beaker, that container in which you are making that curd at the winter time, right? In the refrigerator, the mitosis process slow down. And I hope you might have observed that in the winter, the curd formation takes more than 8 hours or 9 hours in the summer, in the winter season, right? So the rate decreases with the decrease in temperature. If I decrease temperature, the rate decreases, right? Because the biological phenomena is controlled by some of its enzymes, and enzymes work only under optimum temperature of 25 to 40 degrees Celsius, right? And now, if the temperature is too high, if you add lactobacillus to the boiling milk, you can try that. You add a spoon of the curd that is full of the lactobacillus, you add it to the boiling milk. What will happen? Will it make curd? Will it make curd? No, because that boiling temperature will kill the microorganisms, will kill the lactobacillus, and the mitosis process will slow down, extremely slow down. Right? Okay. Am I clear? So rate first increases and then decreases. And you might have been observing this thing to your life also, that you feel lazy when there is an extremely hot outside. These days in India we have a summer season right now, and you might be feeling sleepy. You might be feeling sleepy in the daytime also, right? Yes. Okay, all of you agree with me now. All of you keep sleeping throughout the day. Okay, fine. Because okay, every time, good. Because at this high temperature, what happens? Our biological activity, our enzymes slow down. They don't work so effectively, right? Okay. And in the summer season, okay, in the winter season, and the December month, again sleepy or again active? November, December, active, sleepy. Okay. I think you might be with your in your rajai quilt. Huh? Okay. You feel sleepy in the winter also because temperature is too low there, and the enzyme activity again decreases. But we are highly active only in this temperature range when the temperature is 25 degrees Celsius to 30 degrees Celsius or 35 degrees Celsius. This is the absolute appropriate time, appropriate temperature, right? Are you getting me? Okay. So same thing happened with the media. Okay. Same thing happened with me also. Right? I also feel sleepy in the summer and in the extreme winter also. I am highly active in the month of September, October, November, and then Feb and March and April. But the same thing happened with me. Don't worry. Don't feel ashamed if you're feeling sleepy in my class also. I hope you're not sleeping. You're getting active, right? Okay, fine. Somebody said pressure. How is the pressure going to affect the rate of reaction? And it gave an example. Okay, we can discuss that later on in a pretty specific example. What about the catalyst? What about the catalyst? Yes, yeah. What about the catalyst? If you add a catalyst to the reaction chamber, with it increases. Okay. Yes, you are right here. It changes the rate of reaction. It alters the rate of reaction. Very good. Uh, I think who has given the correct answer? Pranav. I hope you have given the correct answer. Yes, Chan has given the correct answer. It alters the rate of reaction. It changes the rate of reaction. It does not mean always increase. Catalyst can increase the rate of reaction, can decrease the rate of reaction both the ways. It depends upon the catalyst that we are using. If it is a positive catalyst, it will increase the rate of reaction. And if it is a negative catalyst, it will decrease the rate of reaction. Right? Okay.